Yes, nice job, Tori. Yes, point 1 is at 1, 5. And point 2 is at -5, -1. Now for point 1, we know this is your x coordinate and your y coordinate, and we're going to identify that as x1 and y1. Make sure to label it because it makes the rest easy. And then for point 2, x2, y2. Now we just need to plug the numbers into the formula. So I'm going to rewrite it, but instead of the variables, I'm going to plug in the numbers. So x2 right here is -5. Then I pulled the x1 to put there. Then you are going to follow order of operations. So parentheses come first. -5 minus 1 is -6, and bring everything else down. Next step is your exponents. -6 times -6 is +36. Same here. Don't forget to bring down that square root. (36 plus 36 is 72. So we get square root of 72. And then in the calculator, take the square root of 72, and we're going to round to the hundredths place, so 8.49. And what that number represents is the distance between point 1 and point 2. Okay, next one, we have point 1 and point 2, so we're going to write down the coordinates for both of those. Point 1, then label your points. Okay, now I'm going to continue to reference that distance formula and plug the numbers in. x2 minus x1 squared plus y2 minus y1 squared. What's up? This here. When I labeled it, x1, y1, that's where I'm plugging it in.
Oh, that says 2 -2. Oh, no.
Because the equations, yes.
I see.
Yes, with the negatives and the subtraction symbol, that's where a lot of the mistakes happen. If it happens to you, it's okay. And then from here, solving the parentheses first. Yes.
How do you do square root on this calculator? Oh, is it that letter?
Yes. So if you type in 74, and then we'll just put it, and then run Okay, ready for the next one? Not quite. If you're feeling confident and you want to work ahead, you're more than welcome to. Okay, next one. Again, I'm identifying my points. Then I'm going to label them x1, y1, and x2, y2. Once I have them labeled, then I'm going to use the equation. Okay, move on to the fourth problem. You with me? Fourth one, same thing. Start with point 1. So 3, negative 1. Point 2. So negative 3, negative 2. Label the points.
You're just taking off.
Am I? I don't know. Some people are. I had some people with me.
Pretty easy to find.
Get that out. Okay, we're gonna go over here now.
Sorry.
I'm not ready to go back there. No. Okay, that was the harder of the two ways. The other way, most people find a little bit easier, and that's using the Pythagorean theorem. So if you're just given 2 points, the distance formula is great. If you're given a picture like this on the coordinate plane, the Pythagorean theorem works awesome. So here's how you do it with the Pythagorean theorem. Let me see if I can get this all in the frame. Okay, so what we're going to do is we're going to connect our 2 points, and your ID works good as a straight edge here to connect the points. Okay, from here, we're going to draw a right triangle. The Pythagorean theorem is to find the length of sides of right triangles, so that's what we are drawing. You may recall when you use the Pythagorean theorem, the legs of your right triangle are A and B in the equation. and then the hypotenuse is c. So in our case, we're trying to find the length of the hypotenuse, which is c. A and B, the legs are interchangeable. It doesn't matter which one's A and B. Okay, so we need to find the distance of A. 1, 2, 3, 4, 5, 6. It is 6. And the distance here is 6 as well. So now we're going to plug these numbers into the Pythagorean theorem. So 6 squared plus 6 squared equals c squared. And then the last step is to take the square root of both sides to get c by itself. And you get 8.49, rounded to the nearest hundredth. And you'll notice that your answers match. It's just two ways to do the same thing.
On the back, you see both.
So on the back it's broken up. You have 6 with Pythagorean theorem, 4 with the distance formula. It's all right, Paxton. You're good. Okay, the next one. And the next one, again, I am connecting the 2 points. So this line is what I'm finding the distance of. Drawing my right triangle. Five units here, and 7 here.
Does it matter if it's A or B, like how do you know?
It doesn't matter. The only thing that matters is that C is your hypotenuse. So I'm going to set it up 5 squared plus 7 squared equals c squared. And then again, if you're good, you can run with it. You can do the last 2 without me just check back to make sure it's correct.
So, I need you.
I won't always be there, Paxton. Okay, I connected the 2 points, and now I'm going to draw this right triangle here. One leg is just 1 unit long, and the other leg over here is 7 units. And now I'm plugging the numbers into Pythagorean theorem. And last but not least, the last problem here.
Whoa.
Oh.
Where'd you get that number?
What's that?
7.07.
Square root of 50.
My calculator's broken.
Do the same thing.
Is it, which one do you have?
It's not.
The,
Maybe it's not broken. Maybe it's just.
okay, that's fine. Okay, now the last one, again, connecting the points. Okay, once I have the dimensions of the right triangle, plug it in. And then once you're done with this side of the paper, you can start the back.